Hi, I'm Len Epp from LeanPub, and in this Front Matter podcast, I'll be interviewing Matthew Skelton. Based in Leeds, Matthew is founder and head of consulting at Conflux, where he provides consulting and training for tech strategy and software engineering practices. He has been working on commercial software systems in various capacities since 1998 and published books through Skelton Thatcher Publications, which he co-founded. You can follow Matthew on Twitter at Matthew P. Skelton, and you can learn more about him on his website, blog.matthewskelton.net. Matthew is the author or co-author of 4 books on LeanPub and a number of other books. The books on LeanPub being Team Guide to Software Operability, Proven Techniques for Making Software Work Well, Build Quality In, Continuous Delivery and DevOps Experience Reports, Better Whiteboard Sketches, How to Sketch Clear Technical Diagrams, and his latest book, Internal Tech Conferences, How to Accelerate Multi-Team Learning Across Departments. In this interview, we're going to talk about Matthew's background and career, professional interests, his books, and at the end we'll talk a little bit about his experience using LeanPub to self-publish and his other work with publishers. So thank you, Matthew, for being on the Front Matter podcast.
Thank you. It's great to be here, Len.
I always like to start these interviews by asking people for their origin story. So I was wondering if you could talk a little bit about where you grew up and how you first became interested in computers and software engineering. And specifically, can you recall your first experience with a computer?
Sure. So I grew up near where I live now. So in Bradford, which is very close to Leeds, north of England. I actually was intending to study music. And actually, I've come back to that. Well, I'll maybe talk a little bit about that later. But at the moment, I've been learning trumpet for the last few years, and it's the most amazing thing. So actually, I didn't do a lot of computers when I was growing up. I was really super focused on the musical side. But I spent a year before going to university. I spent a year working as a laboratory technician in a school. So I did lots of practical science, basically. So preparing experiments, getting big laser machines out of the cupboard and preparing bullseyes for dissection and all this kind of stuff. So it's actually super interesting. But I remember actually having a conversation with my colleague at the time, the senior technician, who actually explained to me how computers work in terms of, instructions, addressing parts of memory. And I realized at that point that I had no clue about computers at all, which is kind of an interesting point to start from. I think that little anecdote actually kind of reflects sort of my interest in computers in terms of how they work, not just what we can do with them. So I've never been particularly interested in things like computer games or some aspects of kind of building software, but I'm super interested in how they work. So I was at university in Reading in the south of England, and I studied computer science and cybernetics. So cybernetics being theory of control systems, the primacy of feedback loops and understanding systems in terms of multiple feedback loops. So the department I was at was one of the first departments to build autonomous robots, for example, back in the early 90s. That particular course was really interesting in the sense that that they took a real systems thinking approach to kind of systems in general. So we used computers to understand systems, just because it's very straightforward to iterate very quickly using software and electronics and things. But actually, I did a project, for example, on insect vision. So how do insects see? Because there's all sorts of feedback loops in the insect visual system. And my final year project there, I built an autonomous weather station. So weather station is designed to sense temperature, pressure, lightning as well. Using some late 90s control networks and so on. But this is quite early, kind of maybe 20 years before kind of modern Internet of Things, IoT based remote devices and things. But we were doing some stuff using kind of 8-bit control networks at the time. But for me, it was super interesting to kind of really get to grips with the detail of how things actually work, right down to the very kind of lowest level, at the kind of microprocessor level, and down onto the actual kind of bus wire level of how computers work. And then, of course, feel free to forget most of that as you move up the stack. And so then you don't need to think of all that detail all the time, but it's still there. And I think that kind of level of detail has kind of put me in good stead, if you like, because if you know the fundamentals, then although most of the time you forget them, you're never going to kind of really make a fundamental mistake about an algorithm that you're trying to implement in software, or some trying to think of another example, some sort of mistake about how data is stored in a database, or what happens when you make a SQL query, for example. So knowing the real fundamentals can really helps, even if most of the time you can forget about it.
Yeah, that's really interesting. I love asking this question about. I mean, because not all EPUB authors are in tech. But many are, and learning about their first experience with this kind of technology is really interesting. And you're one of very few people that I've interviewed whose first. I mean, lots of people get into the fundamentals at a certain point and find it fascinating. But a lot of people, their first experience is the magic of typing something and then seeing something happen. Even like one guy I interviewed recently, it was in a like he had a scientific calculator that he could program in. And he just found that fascinating. And someone else, it was a bouncing ball on a Commodore 64. But there's the occasional person who it's like, wait a minute, like machines can do this, and get into like the information theory, and stuff like that, and how the gates work and things like that, and so it's really fascinating to learn everybody's journey. And so I think you've already kind of answered this question for me, but another question I always like to ask is, if you were starting a career now in tech, would you formally study computer science at university?
I think it has been super valuable, certainly where I studied it, because we had this combination with computer science, and it was actually the science of computing that we did. We did programming as well, but it was actually there's lots of theory behind it and so on. But we also did practical stuff with robotics and with human systems and a bit of psychology in there. So the course at Reading was actually really good, because it sets people up for a kind of deeper and broader understanding of computer systems than just a programming course, if you like. It wasn't just software engineering; it was a broader thing. So, a course like that, where you do get to see a bigger picture, you do get to see some of the theory, some of the fundamentals behind it. I think it can be really valuable. But actually, I was thinking about this recently. I think what we really need in the industry is not just people who have done. Who had some experience learning about kind of software and computer systems. We need people who have done psychology, people who have done philosophy and ethics, people who have a sense of history, people who understand design. In other words, we need people from across the spectrum of human kind of interest and awareness building software systems these days, having input into building software systems, because software systems are becoming so prevalent, so all-pervasive in touching all parts of our lives, from agriculture, healthcare, not just banking and shopping, which it was for the last 20 years, but they're starting to touch everything. So we need a diverse range of people, a full kind of spectrum, if you like, of people from all sorts of walks of life, feeding into and contributing to how we build these software systems. So I think it's important that we have some people who have been to university and studied the fundamentals. I think it's important we have some people who have come straight from school and have learned their kind of craft as a programmer or as a systems person. But it's not just about that either. We also need people who have got very different perspectives, a kind of more of an arts and humanities perspective as well, because this is about society. This is about software affecting the society we live in. So I think we need a really broad range.
Actually, that's. I wasn't planning on asking you this, but one thing that also comes up sort of routinely here is, because I get to interview people from all around the world, is different university systems. What was it like at Reading? Did you have to take electives, or did you only study kind of computer science and sort of cybernetics courses? For example, did you have to take some humanities courses as part of your degree?
It was at Reading. It was mostly. We had some flexibility in what we could choose. There was some crossover, so some people chose to do some psychology modules or some sort of human systems stuff. Most of it was fairly predefined where I was on that course.
It's really interesting. I think because what you were saying sort of corresponds much more to the kind of North American model of what an undergraduate university education should be than the British one. Which and one thing I wanted to say is, I mean, I may have said it already and I forgot, but I couldn't agree with you more. It's funny how the particular preoccupation I have, because my technical knowledge is nowhere near yours, but I encounter design decisions like everyone else does every day. in software. And an example that I always like to think of when it comes to this kind of thing is bookmarks in Chrome. If you bookmark a website in Chrome, you can only put it in one folder. So if you bookmark it in one folder and then you try to bookmark it in another folder, it moves it to the other folder. And it's like, I can see probably, like I'm going to say the guy there, I can see the thinking of the guy who made that decision. And that is someone with no experience at all, ever, doing research.
Or even no interest in behaviour of people who come from a different mindset to them, possibly.
That you said, precisely. Yeah, and like that, and you can see, like, I've encountered this myself with someone going, why would anyone ever want to do that? And it's like, why would you treat the limits of your own imagination as the limits of imagination itself? You shouldn't relate to your own horizons that way. And this is a problem that we encounter in the things that we use all the time that are designed by people who don't. It's not just that they don't. It's like nobody knows everything, but even lack a kind of fundamental curiosity. And the more that people in their education are perhaps, are sometimes forced to branch out. The more likely they are to understand that there's a world beyond what you know, and that when you're designing or creating things, you need to do it with that understanding. This is actually all very relevant to my next question. So I was surprised to notice when I was researching for this interview that you and I nearly overlapped at the University of Oxford, and you studied neuroscience there.
That's right.
And the typical model of student life there for undergraduates and what they call postgraduates, or graduate in North America we call graduate students, can seem unusual to people unfamiliar with it. And I would venture to say this is particularly true for people more familiar with the North American university model. Most North American, So what was your experience like at Oxford?
So I was on the Master of Science in Neuroscience, and that was quite a radical program. This is back in 1999, 2000, so a while ago now. But it's quite a radical program at the time where they took students from a wide range of disciplines. So I was obviously coming from computer science and cybernetics, but there were people on the course who had backgrounds in philosophy, psychology, mathematics, biology, all sorts of different backgrounds in terms of their undergraduate study, being brought together to do master's level study in neuroscience, and that was deliberate because what they wanted to achieve was this kind of diversity of opinion, because at the time, this is 20 years ago, it's quite clear that we didn't understand. It was quite clear that we understand much less about how the brain worked than we had thought before. Nothing's changed in that respect. We still don't understand an awful lot about how the brain works. It's quite clear it's become more and more and more kind of awkward and complicated and nuanced. And so that was a really great experience, a really great course, because we had this huge diversity of people coming from mostly from the UK, but we had people from North America and a few other places too. And so the conversations that we would spark and the kind of positions that we're coming from led to some super interesting discussions and super interesting perspectives on brain function and perception and sensing and this kind of thing. Maybe we'll talk about this a little bit, but that my experience there has been quite a real strong influence on some of the work I've been doing recently with the Team Topologies book. So outside of the course itself, the learning model at Oxford is it needs a lot of independent study compared to some other universities. So more recently, I did a master's in music at the Open University, which is a university based in the UK, but they've got worldwide kind of presence. I think they've been doing distance learning since the 1960s. Back then, it was kind of sending cassette tapes or videotapes or whatever it was out to people by post. Obviously now it's all online. And the Open University model is super supportive. You get loads and loads of really good materials and you're really guided through the learning and that kind of thing. And that was a great experience as well. Oxford was very much the other end of the spectrum where you're expected to be very independent and so on. So I learned a lot about all sorts of stuff from from that experience there.
I have to ask, what college were you at?
At Brasenhouse College.
Okay.
Yeah. Where were you?
Balliol.
Okay, just around the corner.
Yeah. It's.
Were you there before or after? Were you there?
Slightly
okay,
after.
2001.
2001. Yeah.
Okay.
It's interesting you say that about independence. Just not to go too inside baseball on our listeners here, but this has come up on the podcast before that the Oxbridge model is basically you arrive. And I don't know. I can't speak to the undergraduate experience, although I do know a fair amount about it. But the sort of postgraduate experience is you arrive and you're like a kite that they let you out. And then they tie it to a rock, and then they come back later to see if you're still flying.
Yes.
And it suits a certain type of person, and it very much does not suit another type of person. It's so if you're considering going, keep that in mind. That part of the experience is being alone and doing things yourself. Yeah, and so that sounds like a really fascinating program, and it becomes relevant to the work you do later. Just keeping with the timeline, another coincidence I found when I was researching for this interview was back in 1999, I was working in London for a company that was at the time called Computasoft, and is now called Dealogic. And I remember when they came up with the name, actually. And I found that you've actually worked with them as a consultant. And that got me thinking that when I was there, from 99 to 2001, the company was building a huge database of information on corporate mergers and acquisitions around the world going back to 1995, something that was only possible, at least the way my team did things, because of newly available search technology and the expansion of the internet. And of course, the relevant technology that companies like Dealogic can use nowadays is orders of magnitude beyond, just searching. What would you? It got me thinking. What would you say are one or two of the biggest changes you've seen in the tech sector in the UK, in the companies you've worked with over the course of your career? And I say the UK because sometimes there are culturally specific things that are very interesting that can happen.
Yep. So the first one is obviously the move from desktop to web. So when I started working as a software developer back in 2001, well, I was doing some work prior to that actually. My very first job was as a kind of network engineer, installing Windows 95 machines in schools and colleges around the UK. So that was a long time ago. So I learned a bit about networking and consulting back then. But my first kind of real job was writing software for brain imaging machines and sort of big hardware devices. But I was writing the desktop software. So the big switch since 2000. Well, a little bit earlier than that. The big switch in my career since 2001, whatever, has been this big shift to web-based delivery of applications and so on. Now we're seeing a switch towards an expansion of stuff to include IoT devices. So very, very small devices where a kind of fabric of compute. I guess that's probably. This current wave is somewhat similar to the switch from desktop to web, in the sense. So we've been working, for example, with some manufacturers in the UK, and there is an increased need to be able to grab telemetry and data, metrics data from the machines in the assembly floor or in the processing plant itself. So sometimes that's retrofitting onto existing machinery that might be quite old. Sometimes it's actually deploying new sensor technology that can be more rapidly reconfigured and controlled. And there's starting to be this then bridge between the manufacturing plants and the cloud. So we're scraping the data off the sensors and pushing it to the cloud for analytics and things like preventative maintenance of machines, which can save a huge amount of money. So that's just in the manufacturing sector, but it kind of applies to healthcare, agriculture, and so on as well. So that's a huge shift at the moment where we're starting to see kind of sensing technology being deployed into a huge range of different scenarios, and then that data being pulled up and processed, and we're able to make much more effective decisions about that's actually data driven, that help us to avoid waste, or to better optimize the machinery and so on we've got. So I think that is a big change. I think there's a big change, and I think a lot of organizations are sort of maybe either struggling or might fall by the wayside if they don't adopt that kind of approach.
Yeah, that's really interesting. So I think I get what you're talking about with preventative maintenance. So basically, if you can have more or less real-time data coming from sensors from machines, then you can see the real time lets you know what's going on, but you can see patterns that can help you make changes to how the machine is operating, so that you can prevent faults. Is that the kind of thing that you're?
Yeah, that's exactly the kind of thing. So instead of sending a maintenance engineer out once a year to maintain an escalator or an elevator or something, you detect when it needs maintenance, and then you can avoid sending them out and send them out just at the right time.
Yeah, that reminds me of a really interesting thing I read about. It was actually probably a couple of years ago now, but there was this, I think, famous kind of machine learning experiment that I think it was Google did on like a data center where they set this machine learning algorithm to they gave it control over the basically cooling mechanisms in the data center. So this is like something as mundane as opening and closing vents, for example. And it increased the efficiency of the data center by 15%. And in a competitive world,
that's huge.
That's huge. Yeah. But the idea that companies are like, there's really this kind of, you can imagine it from a kind of C-suite perspective. I mean, really, I can just get the secret sauce if I've got the right sensors and the right computing going on in the cloud, that I can increase the efficiency of my machinery by this huge percentage. I mean, the incentive to get involved in that must be really intense.
Yeah, so that's what's driving all this AI stroke machine learning stroke kind of algorithmic application of data-driven stuff. So I think that is one big thing. I think that the second thing that feels like a big shift is that many organizations haven't really realized that or haven't really taken advantage of the kind of virtualization in cloud and modern practices, and still think that the way in which they're running their kind of thinking and commercial view on their product market, on their products or their market fit or whatever, the way these companies seem to be running is still as if they're going to deploy some software onto a desktop. So there's the people running them have still got a kind of software basically is just about what I can see on the screen. And this is hurting so many organizations because the way in which these companies are prioritizing the software work is basically crippling their ability to innovate, is effectively squeezing their own capabilities. So these sorts of organizations have not taken the time to think about operational concerns, think about testability, think about how easy it is to diagnose a problem, how easy it is to restore a service after it's fallen over. So all they're thinking about is a set of features and pushing those features out as quickly as possible. And these companies are really struggling because they are falling behind their competitors who are able to go much faster, who are able to do things with less effort, apparently, and able to get better market fit because they've completely changed. The companies in front have taken a very different approach, which is very small changes, tested, a really strong focus on testability, on operability, these kind of properties of the software, optimizing for ability to change, rather than just pushing out a big long feature list. And so I think that's been a big change in the UK and around the world, basically, is the way we think about doing this thing called software has really there are new patterns which were really, really successful, but not every company has really understood that that's the way to go.
This is a bit of a clunky segue, but speaking of big changes, on this podcast, we like to talk about people's careers. And in 2014, I know you started your own business at a certain point, but in 2014, you decided to start your own consultancy, if I've got the timeline right.
Yep.
What led you to do that? That's a big decision.
So at the time, this was when the DevOps movement was still fairly new. So I attended one of the first DevOps Days events. It was actually in Hamburg back in 2010. I gave a quick lightning talk there. So that was only 1 year after kind of the whole DevOps thing really kicked off. So it'd been going a few years, and I've been working for a couple of different companies in London at the time. But I decided actually the market was kind of right for me to like have a go at it alone, basically, just to see if it could work. It also coincided with a moving house from London to Leeds, where I now live. So it was a nice opportunity to kind of just have a clean break.
Yeah. Was there any particular reason to leave London? I know that it's I lived there for a few years myself, and it's a very exciting place, but it can also famously kind of wear on one.
Yeah. So look, London's great, and there's so much opportunity, so many amazing things to do. I appreciate living here. The air is cleaner. I can reach 7 different national parks within a day, so I can get out there and go walking and be in the open air. And this is kind of where I grew up, so I know it quite well. So it was nice too. It was a great time in London. I was there for 10 years, but I love living where I do now.
Fantastic. And actually, I wanted to ask you a couple of questions. So you've founded the London Continuous Delivery Meetup Group, which has thousands of members.
Yep.
How did that come about, and why do you think it became so popular?
So I founded that back in 2012. Or co-founded. So I was giving a talk at an event called Web Perf Days, which was associated with Velocity, the Velocity conference from O'Reilly at the time, and it was taking place in London. And I did a talk on how continuous delivery is shaping software architecture. This was at the place I was working at the time. So I was talking about things like a focus on deployability, a focus on detecting problems, a focus on testing, things like this. And the room was packed. The room was absolutely packed. There were people like who couldn't even get in the room. It was so full. And so I thought, that's really interesting. People seem to want to know about continuous delivery. Of course, the book called Continuous Delivery by Jez Humble and Dave Farley had been published 2 years before, so it's still fairly recent. It was probably less than 2 years between the publication of the book and my talk at the time. So I just asked people at the end of the talk, look, if anyone wants to meet me after the session and talk about maybe doing something around continuous delivery in London, then let me know. There was a chap, Dave, who came and had a chat, and we decided, well, let's make a go of it and let's see what happens. So I was running that meetup group for 7 years, 8 years. I've actually just handed it over to some folks from a company called Engineer Better, who have been really good supporters of that, and the conference, Pipeline Conference, which kind of came out of the meetup group. So Pipeline Conference we ran from 2014 to 2018, and that was kind of created and founded and run by people who were involved in the London Continuous Delivery meetup group. I think it's the group is an amazing experience. There's so many good people I met there. I'm so grateful to have had the opportunity to work with all those people and to be able to hear what they had to say and so on. And it is a really great community around it. I think one of the reasons why it worked so well is because we avoided a focus on tools. We did have some talks about tools when it was appropriate, but we avoided it just becoming about, hey, here's 1.7 version 1.7 of this tool, and well, look, here's 1.8, and look all the new features it's got. So we avoided that kind of thing, which is fine and useful, but we made sure we had a kind of broader appeal. So we had talks on product ownership, we had talks on testing and testability, we had talks on version control and branching, the whole range of different kind of practices. It was more of a practice-based thing. So it appealed to quite a wide range, and we moved around different offices, so different companies. We moved around London each month, so we got to see lots of different locations, and we got to kind of partly promote quite a lot of different organizations different companies as part of that.
And just for those listening who might not know, what is? Thank you for sharing the story.
Yep.
What is continuous? If you could explain what continuous delivery is, because this is another sort of big change in the way things are done, basically.
Yep. So continuous delivery, as defined by Jez Humble and Dave Farley in their book 2010, is reliable software releases through build, test, and deployment automation. Quite often people think continuous delivery is just about pushing code to live when we're done. But it turns out in order to do that effectively, we have to actually think about a whole lot of other things. We have to think about kind of team ownership of software. We have to think about our version control practices. We have to think about how often we're merging our code with other people, a whole lot of other kind of practices and kind of team interactions and individual interactions between people to make this stuff work really well. What's interesting about the continuous delivery book is I'm still waiting to find some practices that Jez and Dave recommended. I'm still waiting to find some practices that no longer apply, but I can't find any. Like I'm always lucky how it was a great book in that sense. Like they made sure it wasn't too technology specific. It was really focused on kind of fundamentals with some good examples. But I mean, there's some new stuff that's come along since 2010, obviously, particularly in terms of things like container orchestration, cloud, and things. But the fundamentals are absolutely sound. So it was really useful to kind of have that as a focus because it effectively it's sort of perpetually useful as a set of techniques, practices.
Yeah, it's really interesting to think about how aspects of our lives have changed because of this. I mean, in the old days, for example, if you were making a product like Excel, you code, test, and then you print. In the old days, discs,
Yep.
And then you wrap them in plastic and cardboard and you ship them out and then people install it on their computer and that's the product until you buy a new version. But nowadays, it's not just the things that we use on our computers or phones, it's even our cars. I mean, if you're fortunate enough to own a Tesla, and that get updated all the time. And it's not just, the updates aren't just always new features. It's like keeping up and just making it continue to work, making things continue to work with the changes happening in the world around whatever the product or service is. And the theory and the management and team practices that have to exist in order to enable that is a really fascinating subject just on its own. So at Conflux, your current company, it says on the homepage that for you, digital technology is viewed as a, quote, organizational sensing mechanism, end quote. And I think that's a great, that's sort of, that's probably, people are probably recalling from earlier in interview when we talked about, things in factories machines in factories having internal sensing and how that can work. But you do a lot of work at the organizational level. And that's just such a fascinating idea. And I was wondering if you could talk a little bit about what it means to think of an organizational sensing mechanism and how it informs the work that you do with companies from multinationals to startups.
Sure. So I think this comes from this comes from a combination of kind of my background in music, and I mean I sing in choirs and I play the trumpet. I'm learning the trombone, various things like this. So I've got a very strong sense of having to listen to other people, like when you're playing in a band or an orchestra or a choir or whatever. There's a very strong sense in which you've got to listen carefully as well as deliver deliver your part, if you like, play your part. But I think that's combined with my the study that I did that we talked about before in neuroscience. Obviously, so neuroscience is all about the brain, but the brain needs sense organs to function. So that's partly why the eyes, the nose, the mouth, the ears are very close to the brain, is precisely because the shortest path between the sense organs and the brain means that the information gets there much more quickly and therefore can be processed more quickly. And the way I kind of see things is organizations that I kind of see it as if that many organizations are almost like a kind of like blind wombat or one of these creatures that can't really see and can't really hear properly. They're just kind of stumbling around in their environment, not really understanding what's going on. Whereas the organizations that are really able to move very quickly through their environment When I say environment, I mean the kind of commercial environment, the world in which we're working. So they're not physically moving necessarily, although many organizations do have kind of lots of physical moving parts. But you can see it conceptually as the organization is sitting in an environment. If it's not bringing in sensory data about its context, so if it's not listening to Twitter and Facebook, if it's not listening to sales data and kind of website traffic and Google Analytics or whatever, it's not listening to that stuff and understanding how consumers are interacting. If it's not if the organization is not kind of doing incremental sort of software delivery and testing what users actually want to testing the features that users actually interact with and testing which things actually work. If an organization is just blindly just kind of stumbling forward, then it's acting as if it's effectively just knocking into things as a kind of like blind wombat would do in its environment. So the organizations are much more nimble, much more able to kind of move around and avoid crashing into things, crashing into kind of problems like GDPR or crashing into problems like whatever Brexit or some privacy legislation. Then these are the organizations that are bringing in kind of lots of digital data into their organization and acting on it quickly. They've got dashboards, they've got analytics, they've got teams close to the data who are then able to make adjustments and changes to the software they're building very, very, very rapidly, which seems magic to these old kind of blind wombat companies, because we've got the same number of people, we've got the same level of investment, but what they don't have is effectively eyes and ears and noses and so on, antenna, if you like, giving them this kind of sensory input.
I've got a question or two about stumbling around and Brexit to ask you in a couple of minutes, but just on that note, so you're talking about all this. We've talked about sensing just in machines and in now in organizations, but one thing you also talk about is, and this goes, I'm sure, to your neuroscience, your interest in neuroscience and your background in that study. You also talk about cognitive load, which comes down to the individual and the team. And I hadn't put this together, but I'm thinking about your interest in computers and sort of drawing on memory and things like that. And humans have limits. We have these limits to how much information we can be managing in our working memory. And this can actually be part of a management tactics or strategy to think about, like, if I've got a team of, say, X number of people and they're working on this type of project, there's only so much that they can be kind of crunching at a particular time. Can you talk a little bit about that? What is cognitive load and how do you manage that?
So cognitive load was defined in this context by a person called John Sweller back in 1998. And there's the cognitive load is the amount of stuff, if you like, that we can, the amount of information we can hold in our working memory when we're doing a task. And there's three different kinds. There's intrinsic, which is kind of fundamental things about the problem we're working on. So in the case of computers programming, that might be, let's give an example. So just something about Java syntax or something. If we write or Ruby syntax, something like that, it's there. I've sort of absorbed that, and that's just something in the background I just have to work with. There's extraneous cognitive load, which is things that effectively have nothing to do with the problem I'm working on, but which get in the way. So an example in that context would be, how is it that I deploy this software again in this context? Something that's nothing to do with the business problem, that's a kind of distraction. So we want to minimize that. We want to minimize the extraneous cognitive load because there's no value add to that. And the third kind is the germane, what's called germane, which is useful cognitive load, which I actually need in order to help me work on the problem. So if I'm writing some sort of bank account reconciliation algorithm, something like that. I've got to keep that stuff in my head, otherwise I can't actually do the task in hand. So the idea is to minimize the extraneous cognitive load. We've got to have the intrinsic. That leaves more space for the germane cognitive load.
So if I can think of a metaphor, say for not necessarily writing software, but just writing in general, it might be like knowing the language would be intrinsic. Using my writing tool, like my fountain pen or my quill or my keyboard, would perhaps be the extrinsic, and then the germane would be knowledge about the subject that I'm actually writing about. Okay.
Yeah, something like this. And obviously, we want to be focused on, as much as possible, on the germane aspect of cognitive load, because that's where the if you like, the competitive advantage is. If we're in a for-profit company, or that's where that's where we can produce the best outcome for like citizens if we're working on some kind of government-focused system. And this becomes really quite important because if a team is asked to take ownership of a piece of software that is way too complicated, that has way too high a cognitive load for that team, then there's no way they can effectively own it. There's no way they can realistically deploy and test and operate that piece of software as a team, because there's just too much to think about. And therefore, they will start to feel unsafe, if you like. They'll feel like unable to actually own it properly. The speed of deployments will probably go down, or the numbers of the number of problems in production will go up, because they're not actually able to kind of effectively own all of the aspects of the stuff that they're building. So I'm actually just writing a talk. I'm writing some slides for a talk actually next week, which I guess by the time the podcast goes out will probably have happened anyway. And if we start from the viewpoint of needing to make sure that cognitive load is not exceeded for a team, this is a different way of thinking about the size of software systems. So in the past, we've had big monoliths where we kind of deploy all stuff together into one big system that all gets deployed together. There's been a movement in the last sort of 10 years or so towards microservices, where we make where the focus is on very small, very fine-grained set of services and bits of software. But I think a different way to look at this is if we have a team that's responsible for a segment of the system, as long as the software that they're working on does not get bigger than the collective cognitive load of that team, then we're fine. Because if the team's still able to own it, then they're still able to assess the complexity, they're still able to assess the risk, they're still able to do what's necessary to get that deployed in the right sort of way. And so it's a different, it's an angle that I guess strikes me as fairly natural, coming with a bit of a background in neuroscience and cybernetics and things. But I think for other people, it seems like there's not that many organizations really so far that have really considered this. There are some. So, for example, the telecoms provider Twilio has explicitly considers the cognitive load on teams that use its in software internally, and they've spoken about this quite a bit, how they actually kind of assess how difficult some of their internal systems are, or services and systems are to use, and they drive down the cognitive load on the kind of product teams explicitly around that, because they know that if the cognitive load gets too high, those teams will not be able to build and run and own those software systems. So it's starting to be a thing. So it's a very different angle about thinking about how big different parts of the system should be. But where we need to go very quickly and safely, it makes sense to explicitly consider a maximum amount of cognitive load that we expect a team to be able to handle.
Yeah, it's just such a, I mean, we've kind of got to move on, but it's a really fascinating topic. I mean, to take kind of human, we sort of, I think often when we're, conducting business, it's often an instinct to be kind of optimistic, I suppose, but to take into account these fundamental human limitations, I'm sure it's something that like special forces do or something like that, right? Like, like literally like how long can you stay awake?
Yep.
What happens? I mean, if you use stimulants to stay awake even longer, but, you can actually kind of measure how performance starts to change over time, and to think about these kinds of things in the context of running machines is just really, really fascinating. But moving on a little bit. So one thing I wanted to ask you about was, I don't know how much you can talk about it, but I saw on LinkedIn that you recently worked on a contract for the UK's Home Office to work on technology related to immigration. And of course, immigration has been a huge topic in the news in Europe and in North America and in many places in the past few years, in obvious ways I probably don't need to really go into detail about. And I was wondering if you could talk a little bit about the work you were doing for the Home Office, or if you can't talk that much about it, just what you see, how you see new technology might be used to manage information by governments regarding things like immigration in the future.
So I was, for most of 2018, I was engineering lead at the Immigration Technology Division inside the Home Office, yes. So we were... It was quite a big program. There's lots of different teams, and one of the things we need to do is to kind of bring in a coordinated approach to engineering standards. So the kind of coordination across multiple teams. So what's going to be our approach to deployment? What's going to be our approach to logging? What are the detailed low-level ways in which we're going to use logging so that we have the best outcome for the what we call the live service teams, the people who are actually looking at the live systems, kind of like ops, if you like, ops people. So a lot of the stuff we're doing there was around considering what you might call the operator experience, the experience of teams who are kind of running the systems. What do they need to see? How do they need to see it? What do they need to do? For example, if in this particular case, so we're working on systems that were involved in processing processing visas, processing immigration applications, that kind of thing. And if one of those applications got stuck, then someone's case would be delayed effectively for days or hours or days, and that can be kind of quite upsetting, and it sometimes needed the kind of metaphorical prod in the machine, or kind of something needed to be reset. And so the ops people would have some of their responsibilities around kind of looking to see why things have got stuck, if you like, and so like in many situations, many different organizations, not just government, but in all sorts of organizations, the experience of the operators is not front and foremost of the minds of people who are kind of specifying what needs to happen. They're thinking about the primary users of the system. And actually, though, to make things really, really effective and operationally, we actually need to think about what these kind of live service or ops people need to do, and see how they need to search for stuff, how they need to diagnose things. So we did a lot of work around that.
Yeah, that's really interesting. That's relevant to the question I'll be asking you in just a couple of minutes about your book, Team Guide to Software Operability, where you talk about how, keeping in mind when you're sort of building something, keeping in mind how it's actually going to operate in the real world, and then there are people that are operating it in the real world is really important. But just before we get to that, so the inevitable Brexit question. So I was just wondering if you could talk a little bit about your thoughts on Brexit, and perhaps in the context of the tech sector, which is huge and various thing in the UK that, covering all kinds of things. But what's your sense of things, that how do people in the tech sector in general feel about Brexit? Are they worried about, do you hear worries about recruitment? But just, I don't want to frame it too closely. Just, what are your thoughts on this?
So I think it's I think there's a whole lot of different, many different strands to this. I mean, my personal view is that it's going to be hugely detrimental. It already has been detrimental to lots of industries in the UK, and it'll continue to be that. I think it's hugely misguided for lots of reasons. But I think some of the things that Brexit will do is drive. It will drive technological innovation in a few different areas. Agriculture is one, because whereas in the past 40 years we've relied increasingly on lower cost agricultural labourers from other parts of the EU, almost all of that labour has disappeared. There is food, there is fruit and vegetables rotting in the fields in Britain because there's no one to pick it. And so what that's driving is increased automation of fruit picking technology. It's driving investment in vertical farming. So these are large kind of warehouses where we've got plants, crops grown in kind of almost like data centers. It looks like a data center, an old style kind of big warehouse thing with multiple robot kind of gantries and fruit picking things inside the factory. So it's definitely driving investment in agricultural automation. It will drive investment in technologies around healthcare as well, because we have been kind of sadly, I guess, reliant on workers from EU and other countries in our healthcare system. But many of those people have left as well recently, so that will also drive innovation in the healthcare technology space, along with things like automation, automotive, so cars and things, because our car industry is now basically dead since Brexit. So there will be a need to drive innovation in other areas too. There could be a real opportunity. I'm trying to put the best spin on this as possible. There could be a real opportunity to avoid to reduce car usage. I'd look at other forms of transport which are much more sustainable and environmentally friendly, avoid pollution and things. So things like electric bikes. There's actually some manufacturers in the UK, and electric bikes are really taking off. So these are kind of pedal bikes, but they've got a battery as well, and so you can. It's much easier to kind of climb a hill on these things. And obviously, it's fairly easy to make an electric bike compared to making a car. So I think, although I think there's going to be a huge amount of damage done, I think there will actually be an innovation that's relevant to people working in software.
Yeah, thanks very much for sharing those thoughts. You brought up some things that I hadn't thought about before, but it's really interesting when you talk about the sort of, this is something people talk about in the American context as well, but people, for example, losing jobs in car factories at the same time as fruits and vegetables are rotting on the vine, and it says a lot about the kind of work that people feel they should be doing and the kind of work they feel other people
definitely
should be doing. And there's this really interesting, there's this really interesting kind of internal contradiction to the logic of nationalism, let's say narrowly construed kind of nationalism around issues of labor. And when people's forms of work get tied up with their identity, technology poses to some people this incredibly exciting opportunity, and to other people this catastrophe.
Yeah.
And these contradictions are woven into the kind of problems that we're seeing in lots of countries all over the place, right? So, and particularly with respect to automation, it's reminding me of something that when I first lived in London, I had a friend who had a roommate, and he was from near Reading, and we were watching the news, and there was a news story about a bunch of long-term unemployed steel workers who were at a football match for their local football team, and by which I mean soccer to any North American listeners, and they engaged in some a racist riot. And I sort of took the opportunity to ask my friend's roommate, I just sort of put it naively on purpose, but why what's going on here? Why are they doing this? And he said, well, you need to understand, Thatcher closed down the steel mills, and they've been out of work since, and so they're full of resentment. And I said, well, why didn't they do something else? And he looked at me like I was the biggest idiot in the world and said, Len, you need to understand they're steel workers. And it really struck me how, it's the sort of thing I would have been able to give the right answer to if someone had asked me the question, but it was only, really having it driven home into kind of my heart, as it were, that, people can become really attached to a way of living that involves their work. And it might be like a factory job where their dad worked and they got their job because I'm thinking in, gender terms here in factory, but, we have this issue in parts of Canada as well, where like it could be generations since the main breadwinner in the family actually had to go out and seek their own job, because it was always dad made a call to the union, and there's something very unsettling about certain types of change that can make people feel like there's something they're losing, when in fact what they had was kind of very tenuous and artificial in the first place.
I think there's some interesting kind of green shoots of optimism, if you like, around some of this stuff, particularly with some of the innovations in kind of really small computers like the Raspberry Pi and Arduino and these kind of things, where they're obviously physically very small. They literally fit in your hand, so they're kind of not threatening in that sense. And a lot of the coding. A lot of the coding courses that have been developed to suit these kind of devices are incredibly accessible. In fact, so I was involved. One of our partners through Conflux, the Foundation for Digital Creativity, is based here in Leeds, in the UK, and they've done a lot of work with younger people, but not just younger people, with other groups as well. So some of the kind of coding. Like kind of training courses and things, it doesn't even involve typing out code. It involves using kind of drag and drop and configuration things that are at a slightly higher level. So like the concept of an if statement, the concept of a loop, the concept of a decision, but kind of without actually having to type it as a stream of characters, you kind of construct the algorithm on screen using kind of drag and drop blocks. And actually, I was skeptical at first, but actually it was actually really useful, because you're thinking about the fundamentals, you're thinking about the flow of logic rather than actually the typing, and you don't have to worry about the syntax. It generates Python or something behind the scenes, right? So it's actually then runs proper code. But as a much more accessible way of getting into software, it was really powerful. And the kids who are learning this stuff are doing amazing things now. There was a kind of gap in the 90s and 2000s where this kind of stuff really wasn't available, whereas now we've got kind of computers that are much more kind of accessible to a much wider range of people. There's even they're taking this kind of stuff into kind of public libraries and even like old people's homes and things like this, and getting like 85-year-old kind of grandmas to kind of write some code. And it's amazing to see how accessible this stuff is. So I think it's kind of an interesting time where we actually will be able to enable a huge range of people who are not necessarily techies, but they want to do something useful with computers. So one person I was talking to, she does textiles, and she wants to dye wool a certain color, but the wool dyeing process needs the liquid to be like a certain temperature for a certain time. She can write her own algorithm using like a Raspberry Pi or Arduino to test this, and then sound an alarm when the fluid's at the right temperature, and then so she can do her own wool dyeing. She doesn't want to be a programmer. She's a textile person, but she's going to use a computer. She's going to program it in order to help her do something. And I think that's the key to getting to kind of broadening out the use of kind of computers and things to a wide range of people. Is let's not obsess about getting people to be trained up as programmers. Let's get people to be unafraid of writing a bit of code to help them do something else. I think there could be a real opportunity for a huge expansion of kind of how we see and use computers in this kind of context.
It's really interesting. I think we could probably talk about this for
all day. No,
but
I find it fascinating.
Yeah, no. Well, I mean, one thing that I was just really sort of thinking about when you were talking is that the way what people think work is, and for some people, and this goes back to the origins of writing. But my brother, who's an English professor, has a joke that like if you see someone with their chin in their hand, like Rodin's famous statue. Some people look at, wow, that guy's working really hard. And other people look at it and see that guy's doing nothing. And he's just resting. And to some people, the idea that, thinking and writing, which is what programming is, doesn't seem like work at all. And it doesn't feel useful. Whereas moving, it sounds kind of, to put things into these basic terms, but like moving things around and putting things from one place, building a structure. Feels like work. This thing was over here and now it's over there, and these things were just a pile of something and now they're an orderly structure of something. that can feel, to some people, that can feel like real in a way that the kind of typing doesn't, which is why, we have this whole language about like how, I mean, of course there's nothing ghostly going on when you're interacting with a computer, but we use terms like virtual to describe the things that we do with it, because we have, I mean, generally speaking, because there's just something kind of, I mean, not to go way off into the philosophical weeds, but there's something kind of uncanny about the invisible work that's done by a computer compared to the kind of mechanical work that and it's interesting, we talk about, nowadays we say technology to mean computers, when of course a chimney is a form of technology. Policing is a form of technology, but what we see as real and what we don't are sort of seem to be very, very deeply ingrained in us. And for some people, what you're talking about, being trained as a programmer just sounds like, oh my God, that's the last thing I ever want to do. It just seems kind of fake and unreal. And by making the way you program more kind of tangible, that might actually really serve to make it seem more like real work to people. But not to hijack this too much, just moving on. So you brought up operability, and so just one or two questions about your book, Team Guide to Software Operability. So this is a really interesting book where you and your co-authors talk about how, quote, you should treat software operations as a high-skill, value-add activity, not support tasks, end quote. Yep. And I like this idea. You talk about how often companies will kind of devalue the operational side of things and call them non-functional requirements as opposed to operational features. And you can just see the kind of like, I don't know, the kind of non-technical executive going like, why doesn't our website have this button working yet? And you're like, well, because of this blah, 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 blah is the ops stuff. And people really need to think about that as features rather than just blah, blah, blah. Yeah.
So, I mean, this is based on the work that we've been doing for a long time, really. I remember when the first kind of logging system that I put into place was for a long time ago now, back in 2002, 2003, I was writing software for the oil and gas industry, where we were taking data from sensors that were at the bottom of the oil well. So this was like hundreds of degrees Celsius and many, crazy amount of pressure. And so we had to then grab that data and remove all the errors and then display it. And so we had to log quite consistently and carefully what was going on, so that we could, because once you put a sensor at the bottom of an oil well, you can't take it out. It's cheaper to drill a new oil well than it is to take the sensor out and replace it or to repair it. So you're talking about kind of an expensive situation. So I actually kind of developed some logging which was really robust and resilient, and the software itself had to be super kind of resilient so that it wouldn't crash halfway through the data collection, this kind of thing. And so I guess I've sort of had to work in situations where kind of the operational aspect of the software was always kind of front and foremost, because of the sensitivity, or because of the cost of getting it wrong. Then a few years later, I was one of the kind of lead software architects on a big system for the London Stock Exchange. We were building out one of their not their primary trading system, but their kind of secondary system. And we made sure to put kind of operational concerns to the fore in that one. 10 years later, so I caught up with a colleague of mine who I was working with at the time, caught up with him actually just last year. 10 years after we launched it, the software is still running. And so the operators, 10 years worth of, I mean, obviously it had been modified and so on and improved, but the foundations were still the foundations we put in place back in 2008. So that kind of brought it home to me how this focus on kind of operational aspects of software can help organizations to get the most out of the software they're building. So that the software is not falling over at times, so that it's easy to diagnose what's going on if there is a problem. We've taken a team first approach with this team guide to software operability and its companion books as well. So testability, business metrics, and releasability, because we wanted to demonstrate and share some practices which work well in a team context. It's not just about an individual developer or tester learning some skills. It's here's how to do some stuff at a team level. Here's how to share information. Here's how to co-discover, in this case, co-discover some kind of operational requirements, co-discover how to define whether the software is ready for service, these kind of things. And it's proving really valuable to lots of different people. So we were at a conference, Continuous Lifecycle, in London a few months ago, and we brought with us some big kind of tabletop size printed sheets with some kind of like operational questions and things like this on. Every single sheet was taken by people because they heard about this stuff and came to the stand and took them away. They realized the value of actually having the entire team sitting around a table and discussing in detail all the aspects of operational readiness that this big sheet covered. So if we're finding that this kind of team focus on operability and similar aspects to be really resonating with people in organizations who are struggling with some of these things.
Yeah, it's really interesting. You write in the book about how most, even books that are about teams are kind of written to the individual. Whereas this book is actually written sort of to be read by a team.
Absolutely, yeah.
Which is just really interesting. One thing actually I wanted to talk to you about is Conway's Law. So I know this is a big topic, but if you could maybe spend a couple of minutes explaining what Conway's Law is, because it's a very important concept.
So when I first came across Conway's Law, I think it was through Alan Kelly, a UK-based software person who's lots of experience and gives great talks. So Conway's Law being this kind of mirroring that occurs between the communications between parts of the organization and the kind of system that the organization builds. So the way that Mel Conway described it in 1968 was basically a constraint on the kind of software systems or the kind of systems that an organization can build. The original 1968 paper by Conway is actually really, really interesting. There's loads of stuff in there. And a lot of people don't actually read the full paper. It's definitely worth digging that one out. It's called How Do Committees Invent? And there's loads and loads of gems in there. What actually is a really interesting thing about Conway's Law is that it's actually it's a really strategic limitation on the organization. So in the paper, Mel Conway talks about it being this mirroring force being a constraint on the solution search space. So an organization that is set up in one particular way with communication between teams or between different people in one particular format almost certainly will not discover certain kind of solutions. It will not discover certain kind of software architectures. It will not discover certain kind of ways of doing stuff just because of the way it's communicating within the organization. And that's an exec level limitation on the organization. When we're doing this kind of knowledge work, when we're in a fast-moving, rapidly changing context, using software to give us that kind of leverage that enables us to adapt things very quickly, because obviously that's one of the main advantages of software. It's not just about processing information; it's about the fact that we can adapt it very, very, very easily. Then your organization design can constrain the kind of things that you're actually able to do as an organization. And that should set alarm bells ringing for any kind of exec or C-level person in an organization, because they might be trying to do certain things, but their current organization design is actively constraining or actively limiting the likelihood of them actually being able to come up with a decent system or solution to a particular market problem.
And so when you say organizational design, just to sort of drill down a little bit, do you mean, like, for example, I'm thinking like, I think I'm sort of recalling a talk that I watched you give on YouTube, I think, where you talked about how there were sort of different financial incentives for employees came in the form of not just salary, but also kind of bonuses. And these bonuses were linked to, if you did 10 tickets in a week or something like that on the support desk, you'd get a bonus. But then there was some incompatible type of bonus, that was doled out to another different team. And I guess I'm just sort of trying to think about this at the theoretical level. If you construct if your organization is designed around bonuses for reaching targets, there might be certain types of solutions that your organization just can't.
No, indeed, yeah.
Do.
Yeah, and likewise, if your organization is very hierarchical and needs information to flow up and down a kind of permission tree, so that it hits the person who's highest in the organization, and people lower down can't make decisions, then again you'll be limited in the kind of solutions that you can come up with. Lots of organizations more recently have sort of found that a really effective sort of template, if you like, for the design of their organization is to have sort of smallish cross-functional teams, so a mixture of skills inside the team, up to about between 5 and 9 people, maybe something like this. And they're focused on one specific part of the business domain. So it might be accounts versus payments versus orders, or something more specific than that if it's a larger organization. And one of these teams, has basically all the skills it needs to go from idea to realization of that idea in working software. Now, it gets a little bit more complicated when we've got hardware and the real world involved, because it becomes really difficult to get a cross-functional team that can do both cloud software and physical hardware design. But that's kind of a slightly more advanced sort of topic. But generally speaking, if we can get a team that can take an idea through to that idea being produced and running, they're more involved, they're more engaged, they're also closer to the information. That team sees how stuff runs in production. Effectively, that team then starts to become that organizational sensing mechanism. It starts to become a little bit like eyes and ears. They're so close to how that stuff is running that they're able to then get that information and kind of bring it back into their design, build, run process, and effect change really, really quickly. And this kind of model is sort of backed up by recommendations from, for example, Stanley McChrystal, who was a former general in the U.S. Army, who over the period of one of the Gulf Wars realized that they had to fundamentally change how the Army worked. The U.S. Army had to change from a very kind of command and control hierarchical thing to a much more kind of distributed kind of control where intent was specified centrally, but then execution was devolved out. And this seems to be an effective model for going quickly, safely, where the world is changing rapidly and where we need to be able to respond to what's out there. We can't predict what the world is going to be like in even 6 weeks or 2 weeks' time. We need to have devolved some of the decision making.
Yeah, that's really interesting. I've read a little bit about that, about how instead of take that hill by doing X, Y, and Z, you send out a team of soldiers or Marines or what have you, and say take that hill, but you guys figure
out how to do it.
You guys figure out how to do it yourself.
Yeah.
And so there's this autonomy and empowerment that the team is given, but crucially it has to be guided by a clearly communicated goal.
Goal or intent, yeah.
Goal or intent even a little bit more vague. Yeah. But the clarity of communication becomes even more. I mean, I was just actually interviewing someone who worked at Spotify just the other day. I was not that he worked there, that I was interviewing him just the other day. But this idea that all this decentralized autonomy comes at a cost. There's a price you have to pay, and the price you pay is communication. You have to pay a lot more. You have to put a lot more focus and thinking into how you communicate when you have kind of decentralized autonomy in this way. And on that note, your latest book is Internal Tech Conferences, which is all about communicating and finding, letting organizations know how much they know to some extent, which you wrote with your co-author Victoria Morgan Smith, who works at the Financial Times. And so I was wondering if you could talk a little bit about that book. How did it come about that you and Victoria decided it would be worthwhile to write a book about running internal tech conferences for organizations?
So this goes back several years, I think 5 years or so, when we were both at a conference in London, and Victoria had done a lightning talk on her experience of running their first tech conference internally. And I had, at that time, I'd been running effectively the same kind of thing, internal tech conferences at the company I was working for at the time. And we just got together and decided to kind of collaborate a bit. We wrote an article for InfoQ on exactly this, internal tech conferences. We interviewed a few other people from different organizations and kind of compiled a kind of initial, here's some ideas on how to do it based on our experience at the time. And then fast forward to last year, we realized there's a few more companies who are out there who had actually been doing this and been writing about it, and there've been some different ideas. So we decided to kind of expand what we'd already written, expand our experience. I mean, since then, I'd run some more internal tech conferences. I'd helped other people to do that as well, and Victoria had run several more years worth of these events at where she works at FT, and so it felt like the right time to do it. And so we got some great case studies in there from a few different organizations, and it was nice to be able to follow up on some of the early material and see what's changed. Some of the technology has moved on as well since sort of 2014. So things like, full screen video conferencing type technology is now basically ubiquitous. I mean, I'm talking to you across an Atlantic divide, and it's perfect, basically. Like the quality is great. So that's just an amazing enabler to be able to kind of reach remote offices. If you've got an internal tech conference day and actually you want to bring in speakers from across the other side of the world, it's basically doable now, which is an amazing. Really, it's an amazing thing. It's magic, basically, as far as I'm concerned. So there's some of the technology's moved on to an extent where we've got more opportunities for including more people in these kind of events.
Yeah, it's really fascinating. One of the sort of themes of the book, and then the whole idea of having an internal tech conference is that often people end up being siloed kind of naturally within companies, and this has the effect that you can kind of be reinventing the wheel all the time, but it also means that people don't know what everybody else is doing, and you don't really have your sense of what your work is all about what you do every day. But actually you're part of a big organization that's doing all kinds of different things, and understanding that you're not just how the whole thing is operating, but that you're playing a role that's useful in a particular way, and so is everybody else, and it all kind of ties together that an internal tech conference can really help people understand what they're doing.
Exactly, and I think it shows a good degree of organizational maturity when an organization actually decides to run one of these things, because you're doing lots of things. You are you're investing in people, individuals, in terms of preparing a talk, preparing them to be a speaker. You're investing in different groups in the organization because you're able to showcase what different groups have been doing. You're also being honest as an organization about how important certain things are. So you might say, hey, we've just built a brand new relational database. And then if you present that at an internal tech conference, and most people probably say, well, why didn't you just use MySQL or SQL Server or Postgres or Oracle or whatever? Maybe there's a great reason, but actually maybe you just wasted, like many years worth of people's time. And so it's a good kind of organizational sort of health check or way of kind of validating what you're doing as an organization to run one of these kind of events, because you have to be you have to surface what's going on in different parts of the organization and work out what it is about what you're doing that's good and worth celebrating, what it is that maybe has been more difficult, and you'll still want to share it because you want to bring that to the surface and get some feedback from people. The organization has to be mature enough or kind of transparent enough that people feel safe to be able to do that kind of sharing. So it can really help to raise the game. the organization where I ran these internal tech conferences, what we did was every 6 months we ran a half-day event, and we actually invited everyone. So at the time, the organization was about 300 people in size. So everyone was invited. So the technology team was about half that, but we invited like legal and HR and marketing and all the different departments, and it was brilliant because we were able to kind of demonstrate what was inside this technology machine, if you like. And it really helped to build some bridges with other parts of the organization. They really started to understand why it takes so long, because we've got to do all this migration stuff. We've got to test the backups. We've got to, physically it takes like 2 days to move that data out of the data center. Oh, well, why can't we just use the cloud? Yeah, exactly. Let's use the cloud then. So it really helped to kind of open some eyes and get some buy-in to some of the stuff we were doing at the time. So I think it can really, really help an organization to run internal tech conferences. It really helps an organization to raise its game, basically.
It's really interesting too. There's all this kind of high theory, but one of the themes of your work is that the operations. It all comes down to operations in the end. And on that note, one of the great things about the book too is that like all of this great stuff only works if it works. On that note, I wanted to ask if you could talk a little bit about the importance of food at conferences.
So Linda Rising, who is expert in organizational change, and she's written several books in this area. One of her patterns that she talks about is do food. So when you're trying to affect organizational change, make sure you do food, and that's because food brings people together. It has to be good quality food. It can't be a few limp sandwiches and some cups of fizzy pop. It has to be like good food. It's worth spending on. People feel like they've got something different, something that's worth eating. But there's actually been some studies. There've actually been some like academic scientific studies done on this stuff with different groups of people, and the groups that had like cake or food or whatever performed significantly better than those without. And so like even at just that level, you have to make sure that food is part of the mix. But it brings people together. It's a nice way to make sure that people can mingle, because it's a kind of neutral space over lunchtime. If you're doing a full day tech conference, internal tech conference, then the food can be acts as a stimulation for like a wide range of different conversations at lunchtime. People mingling all together and talking about the morning events and talking about what might happen in the afternoon. So it would be a big mistake if you're running an internal tech conference. It would be a big mistake to have no food. It'd be a big mistake to have poor food. You have to have food that people are going to remember, that feels nice, so it feels like a special event.
Yeah, and it needs to be on a number of different levels. It needs to be seen as as desirable and enjoyed. When people go, and so it's really interesting. Just moving on to the last part of the interview, where we talk about your experience writing. So you've written a book with O'Reilly, I believe, Continuous Delivery with Windows and .NET.
Yep.
And you're currently working on a book called Team Topologies, Organizing Business and Technology Teams for Fast Flow, which will be coming out with IT Revolution Press. But in addition to sort of your sort of conventional publishing books, you've also decided to publish some books on LeanPub. And I was wondering if you could talk a little bit about why you decided to do that. So
the first book that I worked on through LeanPub was called Build Quality In. This is back in 2013, and we published it in early 2014. Collection of DevOps and continuous delivery experience reports from around the world. And so I was one of the editors, along with Steve Smith. And what attracted us to the LeanPub platform was it was several things. Firstly, we could, as techies, we could write the book in Markdown, which is great because that felt really natural. So we can collaborate using version control in Git, and then just push the changes, and it would trigger a build, and then we get the nice new PDF coming down through Dropbox. I mean, it was kind of when I first came across it, I thought, wow, this is genius. This is like it's kind of the simplest mechanism that can actually work, and it still works really well. It really appealed that. The kind of if you like the operational side, the kind of techie side behind it felt very nice. But actually, the model, the Leanpub model of publish often and get feedback, also felt something that tied in so closely to all the stuff we were doing. Like, we're literally writing a book on continuous delivery. So let's use a publishing approach which feels very similar. So it felt really kind of important for us to actually to follow that model through and to be able to do it like that, kind of incrementally, and get some feedback. It's been good since then to use the platform, because the support we get has been really great. If occasionally we'll find a small problem with something, and I kind of emailed in, and then within half an hour or so, 30 minutes or something, get a response back saying, "Oh yeah, we've found that problem, and it's going to be fixed soon, and it's fixed in a couple of days," or whatever. So the kind of responsiveness as a user or as an author or publisher on Leanpub has been awesome. I can't imagine there's another platform that has that level of responsiveness for digital publishing. I think it's really good.
Yeah, well, thanks for the kind words, and for sharing that story. That's really interesting. I mean, one of the ways we've decided to build Leanpub is to listen very closely to what authors are saying. That doesn't mean do everything they want,
exactly.
But we try to treat every kind of genuine signal as a problem to solve. Mm-hmm. And that's kind of what makes it sort of makes support interesting. If for example, if you get to treat it as a puzzle that needs to be solved, and so if people are, this is kind of normal kind of startup stuff. But if someone's found a bug, well, that's a bug. Try to fix it as quickly as you can. But
mm-hmm.
Then you treat it. But why did that bug occur in the first place?
Mm-hmm.
What's the deeper kind of structural issue there? And part of also one of the reasons we can have confidence that what we're hearing are signals is that so many Leanpub authors are technically minded. I mean, they're writing books, right? They're probably smart people to begin with, but we've got all these technically minded people who actually will send us screenshots showing the kind of console in kind of Chrome or whatever,
Yep.
with the error messages, people, so anyway, we're very fortunate that when we get reports of issues, actually people often know how to communicate in ways that make it easy to solve, or easier to solve. So the last question that I always like to ask people on this podcast is, if there was one thing we could build for you or one thing we could fix for you, what would you ask us to do?
It's a really good question. So the thing that immediately came to mind was actually just discount codes. So it's currently, you've got the coupon thing currently, which is like a URL. But actually just being able to because the URL is it's difficult to shorten, it'd be nice to be able to copy and paste the discount code into the checkout box. That would certainly help in lots of cases, I think.
That's really interesting. So you're the second person to say that in the last 3 interviews I've done, I think. The answer is that if someone has a coupon code, they need to enter it somewhere, which means that there needs to be a coupon code box. When we used to have this. But when a normal customer goes to your book's landing page and they see a coupon code, if they don't have one, they might not buy your book.
They get sad. Yeah.
They would have, because they think, a lot of people just don't care. They're they want the book, they're going to buy it. If the price is right, that's fine. But there is a certain type of customer for whom that is a very unpleasant experience to see, there's a coupon code. If only I had it, then I could get the discount. And then so what they might do is try contacting you. And so now they're legitimately, but now they're taking it on Twitter or through email or whatever. And they're hey, Matthew, can I get that coupon code? And you're well, the coupon code expired, because it was only for during this conference. And then they're well, what? But there's still a coupon code box on the landing page for your book. And so actually having coupon code, for those who get it and get to enter it, that's a great experience. But for everybody else, seeing a coupon code box when they don't have a coupon code kind of sucks. But and so that's the reason we decided to go with coupon links. So you get a link and you go to and then you go to a page that's sort of designed for that coupon link.
Yeah.
But we're always willing to revisit decisions that we've made, and since you're the second person to bring this up, we take that as a strong sort of signal that there's something that authors are doing that or want to do that solves a certain problem for people that we're not offering right now.
I think one other thing that could be really interesting, which is harder, which is much harder, would be some sort of plug-in mechanism into the generation process that would allow additional checks to be plugged in. For example, the service is it called Grammarly? One of these kind of like grammar checking and style checking things. Yeah. But imagine something where you could plug into that and have something do a tiny bit of kind of like copy editing type assessment into the PDF generation process. That'd be a bit awkward because you're effectively running someone else's code. But if there was some way to kind of hook into that, because that could be a super interesting thing, because I can think of a whole lot of stuff I would want to write to assess all sorts of stuff about what the authors have written. And this is coming from the viewpoint of a publisher now. So through Conflux Books, the internal Tech Conferences book is published through Conflux Books, and that's the first of hopefully many different books we're going to be publishing. So in that guise, I'm actually acting as a publisher or editor, and it'd be nice to be able to do a whole lot of editing checks automatically. But be kind of cool to have like a little marketplace or something like this where we can kind of enable that plugin for checking grammar and enable this plugin for checking spelling, enable this plugin for checking something other kind of style things and getting output during the build process. That could be cool.
That's a really interesting suggestion. A couple of things I would say about that. One is that the sort of furthest reach of what you're describing is, imagine I could click a button and the book would be translated into, a bunch of different languages, and there'd be an audio book. These are the kinds of things that technology actually there's certain types of books where I don't believe machines will ever be able to properly translate them. But with the kind of prescriptive nonfiction kind of books that are sort of, typical of LeanPub books, actually kind of automated translation is something that is probably achievable. A book about how to learn Git, that's probably something that actually could be translated if it were written in the first instance in the right way. Yep. So the sort of like space age version of what you're asking for is click a button and the book gets translated into lots of different languages and audio book versions are created and stuff like that. But so then on another level, it's like, can I hook various services into what happens when I generate a LeanPub book? That's something that, like, because of what you're talking about, as you mentioned, kind of that's other people's code, stuff like that. That can be very complicated. But one thing that is not so complicated is us showing authors, like directing authors to these different services, because, sort of like, even if we can't build or won't, or, it would take too much time, or we might do it someday, but there's nothing stopping us from providing these resources to authors in, our help center or somewhere in our documentation, saying like, hey, by the way, one thing you can do is you can just upload your manuscript here and run it through this service, and then you'll get this. Because we have one guy who he speaks English in the way Germans do, which is very well. But when he was writing, he was a little bit less confident. So what he would do is he would write in English, and then he had this online service where he would translate it to German. And then he would copy and paste the translation from that service, and then paste it in again and translate it back into English. And so he would iterate on his sort of grammar checking that way, and surfacing to authors these kinds of practices and services, is whether we build features or not, is something that we could definitely help people by doing. Well, thank you very much for those suggestions, Matthew, and thank you very much for taking the time to do this interview. And,
that's right. It's been great.
And thank you very much for using LeanPub and for being a LeanPub author.
No, it's great. It's great to be part of it. Thank you.
Thanks. And thanks, as always, to all of you for listening to this episode of the LeanPub Front Matter podcast. If you like what you heard, please rate and review it wherever you found it. And if you'd like to be a LeanPub author yourself, please go to our website at leanpub.com. Thanks.